Hi guys, welcome back. This is probably my favorite lesson of the year. It is our beginning of calculus. What the heck is a derivative? What does it do? I love this one. So here we go. Wish me luck and I wish you luck. Okay, so what I'm going to do right now is really weird. I'm going to just show you the actual math of the easiest version of a derivative. I'm not going to even show you what it means yet. I'm going to show you what it means and what we can do with it after I show you the mechanics of getting it done. So, power rule, the most basic of derivatives. First of all, some notation. This symbol right here, the F prime, means find the derivative. If the equation was in the format of y equals, say, 5x squared, blah, 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 more stuff, then they might also say find the derivative by using this notation, dy dx. That also means find the derivative of y with respect to x. Don't worry too much about it right now. Just recognize if you see this, it asks for the derivative. If you see this, it asks for derivative. Now, I'm going to show you how easy the easiest rule for derivatives is, and then I'm going to show you how cool it is and what it does for you. Okay, so number one, to find the derivative using the power rule, get used to using the notation and write it every time. Don't just write random stuff, write what you're finding. They're very picky in calculus about your notation, okay? The derivative is, here's the power rule, take the exponent, multiply by the coefficient. So it's 3 times 2, which is 6, x. Now subtract 1 from the exponent. 6x squared is the derivative of 2x cubed. Okay, now let's do the next term, the derivative of this. Multiply exponent times negative 5. So it's 2 times negative 5, which is negative 10, x to the, subtract 1, x to the first, which obviously we wouldn't write. Okay, how about the derivative of just the positive x? Okay, well, x to the first, if we do the same rule, it's going to be exponent 1 times 1, which would be 1. If we subtract 1 from the exponent, you get 0, but anything to the 0 power is just 1. So, the derivative of x is just 1. Okay, the derivative of a constant. Well, if I use the same rule, then that negative 4 could be thought of as negative 4x to the 0. Okay, if I use the same rule, 0 times negative 4 is 0, and 0 times anything is gone, so the derivative of any constant is 0. Okay, now look back at the original problem. Let me erase all this mess that I have here. Look back at the original problem and look back at our answer and notice that the answer for each term it's just 1 degree less. Okay? So if it started with an x cubed, my derivative is an x squared. If it started with an x squared, my derivative is an x to the first. If it started with an x to the first, then my derivative is the coefficient in front. And if it starts as a constant, the derivative is 0. So now hit pause and try the second one on your own. Okay, let's see how you did. First of all, did you write the derivative notation? Get in the habit of doing that. Okay? The derivative will be multiply. You get negative 12, subtract 1. Multiply, 2 times 1 is 2. Subtract 1 from the exponent. Here, multiply, and you get negative 6x to the 0, which is just negative 6. And the derivative of a constant is 0. This is my answer. Easy, right? Super easy. Okay, now my favorite part. What the heck does it mean and what does it do for us? I love this part. Okay, so switching gears a bit. If I asked you for the slope of a line, the slope of a line we all know. We've been doing that for a long time. The slope of a line is the coefficient in front of the x if it's in y equals mx plus b form. So the slope of this line would be 3. But I can also calculate the slope because it's a constant rate of change. So I could, if I make this a little bigger anyway, let me see how precise I can be. I can also count the squares from one point to another, and I go up 3. Sorry, one moment, technical difficulties. Up 3 and over 1. So I can find, because it's a constant rate of change on a line, using any 2 points, I can calculate the slope, up 3 over 1. Okay, we all know how to do that. But what is the rate of change? What is the slope if it's a curve? So what is the slope of a curve? Well, on a curve, the slope is always changing. That's what it means. It doesn't have a constant rate of change. The slope here, hopefully you know the slope there would be 0, because that would be where you have a horizontal tangent. Maybe you don't know that yet, but we'll get there. But we can see the slope here is different. It's positive. The slope at this spot right there would be even steeper, more positive. The slope here is different. It's steeper, more positive. But the slope in all the different spots along this curve, the slope is changing everywhere along that curve. Well, that is what the derivative is going to find for us. So let's take that parabola, y equals x squared, okay, and let's do the derivative of it. If I have y equals x squared, and I do the derivative using the power rule, the derivative would be 2x. Well, so what? What does that mean? What do I do with that? I want you to think of the derivative as the derivative is a formula for the slope of this curve, but it's waiting for me to tell it where I want the slope to be calculated. So, what is the slope at this spot right here? Well, that's an x of 0, so I would have to plug in a 0 for x. If you plug in a 0 for x right there, then you can see the slope there is 0. Well, how about at 1? At an x of 1 right here, what is the slope there? Well, I would take my derivative and I would plug in a 1 for the x. If x is 1, we get that the slope there is 2. So the slope here would be 2. Well, how about over here when x is 3, way up here? What's the slope at that spot? Now I take my derivative and I plug in that x is 3. And if x is 3, you get that the slope is 6. So you can see we went from a slope of 0 to a slope of 1, or sorry, a slope of 0 to a slope of 2 to a slope of 6. It's getting steeper. Well, how about on the left side of that graph? Let's plug in when x is negative 1. Here's my derivative again. When x is negative 1, you get that my slope is negative 2. Because over here at negative 1, the slope is negative. So, what is this derivative equation? What is that thing finding for you? What is it? It is a formula for the slope of a curve anywhere along the curve, okay? It's just waiting for you to tell it where you want the slope figured out. That's crazy stuff. I mean, seriously, who thinks of this stuff? It's crazy to me. Okay, so let's do an example and try to put it all together. This is asking you to find the derivative at a point. Okay, so we're going to find the derivative in terms of x first. So I'm going to find f prime of x using my power rule. Okay, 3 times 2/3. Yes, you have a lot of fractions in this class. You got to deal with it. 3 times 2/3. I'm going to write it. I want you to visualize it, but in the future you should be able to do this in your head. 3 times 2/3 is just 3 times the top and divide by the bottom. 3 times 2 is 6, divide by 3. So 3 times 2/3 should be just 2. Subtract 1 from the exponent. Then 2 times negative 5, I get negative 10x. The derivative of x to the first is just 1, and the derivative of a constant is 0. So that's my derivative. But now, this question is asking me to evaluate that derivative at negative 1. So now I plug in negative 1 for all of my x's. And I can do that in my head. Squaring a negative 1 would give me 1 times 2 is 2. Plugging in negative 1 here, you'd get a positive 10 plus 1. So I get a total of 13. So the answer to the question, what is f prime of negative 1? The answer to that question is 13. But what does it mean? Okay, if we were to graph the original function, hopefully you know that's a cubic. It's like something like that. So what is this? Hopefully you know from the last slide. This is telling me the slope at negative 1 is positive 13. So I have the actual graph for you to summarize it and actually look at the picture. So here's the actual graph on my graphing calculator. At negative 1, don't confuse the slope with the height. At negative 1, the slope at negative 1, the height at negative 1 was this negative 10. Here's the point right there. This f prime of negative 1 is telling me the slope at that point is super steep, 13. Okay? By the way, something I haven't said, but it's going to come up next. The slope at a specific point on the curve, the slope at a point like right here, it's so hard to use this thing. The slope right here is the same as the slope of the tangent at that spot. I keep drawing my tangents bad. All right, let's move on. Okay, this is a huge question. It won't go away all year. It'll be on the AP exam many different ways, okay? And it's an easy question, and it's the reason that I gave you one of the review assignments that I gave you during Smart Week. Okay, write the equation of the tangent. Well, when you write an equation of a tangent, I want you to remember a tangent, basically an equation of a line. If you're writing the equation of a line, you need two things, forever and always. The two things you need are point and slope. Point and slope, point and slope. Don't forget it. Don't forget it forever and ever. So here's point slope form of a line that we're going to use a lot. And again, we need two things. We need point and we need slope. So the point is going to be the point at negative 1. So you're going to plug the negative 1 into the x equation, and that'll give you your point. The slope is hopefully what you just learned. Slope is another word for derivative. To find the slope, we find the derivative at negative 1. So these are the two things that we need to find in order to answer this question. Okay? This is going to be my point. This is going to be my slope. So the point, f of negative 1, I just plug in negative 1 to the equation, and that's 2 times negative 1 plus 1. So that'll be negative 2 plus 1, which is negative 1. Okay, that's my point. So right now, this notation right here translates to when I have an x of negative 1, I have a y of negative 1. That's my point. But get used to the calculus notation. Okay, now I'm going to do f prime of negative 1. That's going to be known as my slope. But you really need to get away from writing the symbol for slope in Algebra 1 format and get used to writing the symbol for slope in calculus format. All right, well, in order to calculate that, I have to first figure out what is the derivative in terms of x. So the derivative of this power rule, that would be 6x squared. And now I plug in the negative 1, and I get that the slope is 6. So I have slope is 6, and I have a point. Negative 1, 1. Now that I have everything I need, I just plug the point and the slope into my point-slope form. So this is my x1, this is my y1, and obviously this is my slope. So y minus y1, so y minus negative 1 would be y plus 1, equals m times x minus x1, which will make this a plus 1 also. So y plus 1 equals 6 times x plus 1. In calculus, we leave the answer in point-slope form. You don't need to pretty it up. Just leave it like that. But that is the answer to this question. Write the equation of the tangent. Okay? So to summarize, when they ask for the equation of a tangent, you need two things. You need point and you need slope. but try not to write it in the Algebra 1 notation. To find the point, you take this question and you plug it in to the function. To find the slope, you take that point and plug it into the derivative. So you're going to plug in that -1 to two things, the original function and the derivative. This gives you the point, this gives you the slope. So now if you want to graph the original equation on your calculator and graph this equation on your calculator, though you'll have to move the +1 over, you'll see that it checks. This equation is a line that is tangent to this cubic, and it is tangent at exactly -1. I'm going to pause a minute and put that in my calculator so I can show you. So this is the graph of the original equation, y equals 2x cubed plus 1. And now I'm going to graph the tangent. So I rearranged our equation into point-slope form so I could graph it in my calculator. And here is the graph of the tangent. Now remember, we are expecting my answer to be tangent to that curve at what point? At what point are we expecting them to touch? They're supposed to. My answer should be tangent at the point x equals -1. Okay, so let's hit graph and see what we get. So I'm hitting graph now. Takes a little while, but it's going to graph the tangent, and look at that, perfect. It's tangent at exactly -1. Pretty nifty, you gotta say. Take a moment to now do that again on your own. You go ahead and do this one. Write the equation of the tangent at x equals 1. So, how'd you do? Remember, you needed two things, point and slope. We need f of 1 and we need f prime of 1. That's the bell. So f of 1, plugging in a 1 to the original function, I got -8. F prime of 1, you had to first find the derivative and then plug in the 1, and I got -10. Plugging those two things into point-slope form, okay, my point is 1, -8. My slope is -10. So y minus y1 equals m times x minus x1. And that's your answer. Okay, so read the directions on this one, and you'll see it's really the same as the last question. Find the equation of a tangent. Same exact thing, but they just give you the more calculus-looking lingo. Don't let them trick you. So, equation of a tangent, you need two things. You need point, you need slope. This is my point. This is my slope. So we have the point 2, -3. We have the slope is 5. And that's all you need to write the equation of a tangent. Y minus y1 equals m times x minus x1. Easy. Just don't let them fool you with the given information looking more calculus-like. And remember, equation of a line, equation of a tangent, you need two things. You need point, you need slope. All right, last one. Okay, read this and see if you can figure out what it's asking. Okay, this is a very, very, very common question on the AP exam. Okay? Where on f of x, where is there a horizontal tangent? That's a huge common question. Okay, well, first of all, horizontal tangent. What does that mean? This original graph is a cubic. Okay, where does it have a horizontal tangent would be, where does it have a flat tangent, maybe there, here, that would be a horizontal tangent. So what you need in order to answer this question is you need to know a horizontal line has a slope of 0. So when they say where is there a horizontal tangent, what they're really asking is when is the slope 0? And then another word for slope is derivative. So when is the derivative 0? That's what this question is really asking. Okay, so study that right now. It's going to show up a lot. Horizontal tangent means when is the slope 0, which means the same as when is the derivative 0. Okay, so first we have to find the derivative using the power rule. So 3 times a third is 1 and subtract 1. 2 times a half, subtract 1. And the derivative of a negative 6x is negative 6. The derivative of a constant is 0. So there's my derivative. And I need to find when is the derivative 0. That's not the same as saying what is the derivative at 0. I'm asking when does the derivative equal 0? When will this equal 0? Hopefully you can see that this is another thing we did during pause. So now you can see why during the week of Smart Week, Review Week, we reviewed quadratic equations. When you have a quadratic equation set equal to 0, factor it. Find two numbers that multiply to negative 6 and add to a negative 1. And then set each factor equal to 0. And you get your two solutions. Now, what did we just find? What does all that junk mean? Here are my two answers to the question, but it's very important to understand why. Okay, the original function is a cubic. So it's a positive cubic. It might look something like that. Well, I expect it to have a horizontal tangent, possibly in 2 places. One here, one here. Well, what are those 2 places? This is an x-coordinate of 3. Sorry, this would be an x-coordinate of 3. This would be an x-coordinate of negative 2. Okay, take a minute to graph the original function, and you'll see that it has a max and a min at negative 2 and 3. Hope you guys are hanging in there. Good luck with your homework. This is a very, 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 very important worksheet. Please put big old stars by it. Do something to recognize or remember that this lesson today, huge, super important. Everything in there, we'll be doing it all year. Good luck.